So what happens internally in the gun with the bullet? What happens once it leaves the gun, and what happens once it reaches a target? So internal ballistics deals with everything inside the gun itself. This is everything from the explosion of the gunpowder within the chamber and um, that bullet traveling down the barrel. And there's going to be a lot of things to take into account here. But basically, for us, it means the bullet leaving the gun. Okay, so here we're looking down the barrel. We can see an area here to eject the cartridge. Okay, we're looking at the breech face here, and here's a round of ammunition ready to go. What propels that bullet out of the gun is the combustion. And so the higher the pressure, the stronger the chamber needs to be so that the gun itself isn't damaged. You don't want the gun exploding in your hand, for example. That force of the expanding gas has no place to go but out the barrel. And so that movable part, the bullet, moves. So here we see the casing left behind and the bullet traveling down um, through that barrel, and it has rifling to spin that bullet for stabilization. The longer the barrel, generally, the higher the acceleration that we're talking about. Externally is anything that deals with the flight of the bullet from the time it leaves the barrel until it reaches its target. So there could be a lot of properties to consider here. How about the energy that was used to propel it? How big was that explosion to begin with? What's the bullet's shape? What's the bullet's mass? Is essentially how heavy is it? What are the environmental conditions? And those actually matter a lot more than people realize. The wind can move a bullet, especially for a long range shot or a sniper. Sniper definitely has to consider the wind. And in a very long range, it sounds crazy, but a sniper has to actually, in some cases, consider the curvature of the earth. These would be extremely long shots, but that can be true. Rain, humidity, other factors. Okay. Anything that has a forward motion and then gravity acting on it is going to travel in an arc. Okay. Even think about like a water fountain. The water goes out, but gravity pulls it, and that water comes down. Okay. So shooting something out, it's going to go up. Gravity is going to slow it. Gravity is going to pull it. It's going to come back down. So even if we're shooting straight out, picture that you had a desk here, you had a marble, it rolled off the desk. It's not going to keep going straight out like a cartoon character until it looks down and then falls straight. It's going to go out, and as soon as it's down off that edge, it's going to start to fall, and it's going to fall in an arc. That's true for a bullet as well. So, what is this energy of motion? It's literally kinetic energy. There's a formula that describes it. It's half of the mass of the object times its velocity squared. You're not going to have to do math calculations in this unit, but what we want to point out here is that the velocity is a bigger factor than the mass because we're taking that velocity and we're squaring it. We're multiplying it by itself. So that's going to have a much bigger effect than changing the mass. This is going to describe the force of that moving object in a straight line. I'm talking about kinetic energy. The more energy applied to the bullet, basically the faster that bullet is going to travel. Okay. Or if the bullet happens to be larger, the more explosive force will be needed to get it up to a certain speed. So we could play with the velocity or we could play with the mass, changing those things around in that equation and see what the effect would be. All right, so this thing is traveling through the air. It's going to have friction. It's going to encounter air resistance. It's going to have molecules that are in its way, and that's called drag. So as the bullet moves through the air, it literally has to force the air out of its path, and that causes friction. That is why a parachute is going to work. It's going to open up. You're going to have this big canopy. Air molecules are going to be pushed up into that canopy, and decrease your acceleration. You're still going to fall, you're just going to not continue to speed up. In this case, the drag is going to slow down that bullet. One of the things that can help stabilize it as it goes through the air is that spin. Gravity is going to pull it downward. There's a formula that explains the force of gravity here as well, and the effect that that would have. So we could do calculations on that. We're not going to. The point here is simply that it exists and we could figure that out, and this is a known thing. The faster a bullet travels, the less it's going to drop over a certain distance. Because it takes time to reach the target, if it's traveling very fast, it hits that target quicker. If it's traveling slow, it might fall more during that time and it might miss its target. Bullets do not typically follow a completely perfect straight line. They tend to wobble in the air. They sometimes call this pitch and yaw. Um, the spinning helps to reduce that. And then, of course, they're not perfectly straight because there's gravity pulling it down. Now, normally these things are traveling at such a fast speed, and the distance from the shooter to the person in case of a homicide is usually a pretty short distance. So these things tend to be negligible in those cases, but they are factors. Terminal ballistics is what happens when it hits its target. So when it hits the target, it could tumble, it could flatten, it could break into pieces, it could literally melt. Okay, so in this case, look at this as a hollow point, and it's totally mushroomed back and deformed. And so these are some examples of bullets that have had an impact with something. When we look at what it does, we talk about basically the tissue damage. So in this case, this is a ballistic gel. It's basically like a type of jello, except really thick and more sophisticated. And what they're doing is they're shooting these bullets into it and it's slowing down. And what it does is it leaves behind a hole, a channel, a cavity, and then the bullet here we can see is lodged. So in this case, we can see the pattern that this bullet made as it traveled through this object. Well, it's going to do that as it travels through a body too. So one of the mechanisms of injuring a person is called tissue crush. Literally, this thing hits you and it pushes its way through the body, tearing a hole. Temporary cavitation is the fact that the pressure here can expand the surrounding tissue internally and it can open up a larger channel with it. And then we can have some impact shock waves to an extent as well. So the path the bullet takes can be determined by knowing a few things. So if we know the endpoints and we know the impact angles, we can figure out where this thing came from. And so sometimes this is done with lasers, sometimes with strings, and there's different ways to determine these angles. Okay, again, here is a bullet hitting the surface of the skin, for example, and we can see it stretching. Now it tears inward, and that bullet is going to go in. Okay, so now that it's gone in, the skin goes back a little bit, so we have a little hole as it goes in. Okay, now it's in the body. We want it to come out the other side. It pushes the skin out. That skin tears outward, and now we have those jagged flaps outward. So that can tell us a little bit about entry and exit of a wound also. Part of ballistics is also testing. We want to determine, is the weapon even capable of firing? Or was it potentially recently fired? So we might look at GSR, gunshot residue, to know if it was fired recently. Gunshot residue is going to be the burned and unburned materials that are ejected from the gun, and not only from the barrel, but other openings of the gun. And this is normally going to get on the person's clothing, on their hands, on their skin, as well as be carried out into the surrounding environment. This person is firing this weapon into a special tank that has water that slows the bullet's pathway so they can then collect that bullet safely to compare it. So we want to compare these bullets. There are professional organizations that determine standards, and this one is the Association of Firearm and Tool Mark Examiners, the AFTE, and it defines a forensics firearms identification in a few different ways. So, one, determining if a bullet, cartridge case, or other ammunition was fired by a particular firearm. In other words, can you individually identify that that bullet came from that firearm? Okay, bullets and ammunition casings are often found and recovered at crime scenes as well. What are some things you're going to want to know as an investigator? You're going to want to know the type of the gun that was used if you have a recovered bullet. Then you have an idea of what you're looking for. You might know what you need to put into a warrant when you're looking to do a search of someone. What's the likelihood that they were fired from a specific weapon? So, can we figure out the make and model of that weapon? Can we link the suspect to that specific weapon? Okay, so these are going to be important things to know. So one way we could do that is, again, comparison microscopy. Here on the left, we see a match between two different bullets, and here on the right, we see that these two do not match. Now, it is important to know that the only way that you are going to identify that a gun fired a specific bullet is if you have that gun. So it's great that you can recover the bullet, but you can't match that without something to compare it to. So the investigation at some point has to lead to the discovery of a gun. That gun, hopefully, is still operational, not damaged beyond use, because we want to be able to test fire it. So now we test fire it. Now we have a bullet from the crime scene. We have a bullet that we just fired from a gun that we know it came from. We compare those two bullets. If they match these stria is a 100% match here, we know that both bullets were fired from the same gun. But that's the only real way in terms of comparing the bullets. You need the actual gun, and that's not always something that's possible. Recovered bullets can sometimes also be measured to provide some other information prior to having the gun. So we can determine the caliber of the bullet, the type of ammunition, what was the bullet made of? In other words, what chemicals made up that type of bullet? What was the gunpowder made of? Was there any material left on the bullet that came from the barrel of the gun as it scraped that barrel going down it? Um, and what that's going to do is limit the possible range of weapons that it could come from and give you a pretty good idea of what you're looking for. A lot of these things are called class characteristics, meaning they can put something into a big grouping, but they don't necessarily tell us a one-to-one relationship yet. It hasn't individualized or said this is the specific gun. We need the gun to test it to know. One of the best ways to connect a bullet to the weapon is to compare rifling marks that were scraped or inscribed onto it as it went down the barrel. Remember, firearms is a type of impression evidence. A hard object is coming in contact with a softer object and scraping it and leaving a mark behind. In this case, the softer object is the bullet and the harder object is the barrel. Here's a side-by-side comparison of some land impressions and some groove impressions. Okay. And then if you look within those, you're going to see scrapings. Those would be the stria that you look at under a microscope. Rifling can be created in a number of ways. In other words, how was the gun manufactured? The manufacturing process itself, how that gun was made, creates unique microscopic marks that are unique to that gun. And every time you fire that gun, it slightly alters those from wear and tear and from use. So knowing how the rifle was made can tell you something about the types of marks it might leave on the gun. And a firearms expert becomes very well educated in the manufacturing process of guns and tools. So a broach cutter cuts all the grooves out of the barrel simultaneously. Basically, what it does is it takes a cutting tool, a cutter head, and it goes down a smooth drilled out barrel gun. So you're starting with a pipe basically that's smooth, it's not rifled, and you're rotating this down it, and it cuts in the lands and grooves, literally cuts it. Okay, so we have got broach cutters. A button is forced down the smooth barrel, and then the compresses the metal into the grooved shape. So instead of cutting it, you're compressing it, and that thing is hot. So that's called a button. And this thing is forced into it. A mandrel is sort of a rod shaped template, and it has raised surfaces on it. And that's going to correspond to the rifling of the grooves that you want. You insert it into an oversized barrel. So basically, our barrel's a little bit bigger than we want it to be now. Not a lot, but a little bit bigger. We put this object down it, and then the barrel is literally compressed around it, squeezed in it, or hammered by special tools. And it then creates this pattern internally. And then there's many other methods also. So that just gives you the idea that the manufacturing of the gun is um, kind of important. And now, when that bullet passes along that gun, the softer metal of the bullet gets distorted by those shapes that were created during the manufacturing process, and they're now on the bullet. So we can fire another bullet from this gun. We're going to get those same marks that are unique to that gun, and then we can match them. At least that's our hope. So putting them in a big group, again, these are class characteristics. The twist direction, did those spirals go to the right or to the left? What was the twist rate? Remember, we talked about this in a previous video. Was it 1 to 10, for example? Can we figure out the make and the model of the gun? What's the caliber of the ammunition? All of these things are great. Um, and if the number, the size, the twist handedness, the caliber of the bullet, if they don't all match, then you can eliminate them as a choice. And so sometimes we're not matching something, we're eliminating it as a possibility. And we're going, nope, this gun couldn't be what we're looking for because it doesn't match the features that it would have had, even if we don't have the gun itself yet. The individual characteristics, now that is different. That's matching one weapon to one bullet. So the stria are really created because in that manufacturing process of making those grooves and making that barrel and the other parts of the gun as well, it leaves tiny random imperfections that are unavoidable, and they're unique. They're like a signature. In terms of the gun, they're as unique as a fingerprint or DNA. Each time that weapon is fired, that barrel wears a little bit. It's scratched slightly and in unique ways. And these tiny imperfections are imparted on that bullet as well. So think of a barcode as an example of a way of identifying something. The matching process, again, we've already talked about this, but we're going to test fire a bullet from the suspect's gun. We're going to use the same ammunition that was used, and then we're going to compare the test fired bullet to the recovered bullet. Using that comparison microscope, we're looking at those tiny stria or those tiny scratches at the microscopic level. So we're going to test fire that. You can see the water splashing up in here. So that bullet's going to be left behind. It's not uncommon for the stria to not match exactly at every single point. Why? Bullets can be distorted or they can be destroyed on impact. The striations in a weapon are not permanent features. Remember, every time we fire it, it does change it slightly. However, the patterns between two bullets fired from the same weapon are overwhelmingly the same. So much so that the likelihood of it not matching is so small that we're going to say that, yes, it's highly likely, 99.999%, for example, chance that these match. And remember, it is up to a jury to consider that evidence. And so that's probably not the only point of evidence they're considering. The bullet might be one thing. There could be several other points of evidence that this prosecutor is presenting. Shotgun barrels are not typically rifled, and they use small shot instead of bullets, although you can have a shotgun barrel that is rifled, technically. Stria are not typically useful for shotgun identification, therefore. What could be helpful is the wad if it's recovered. It can often be related to the gauge of the shotgun. Can even tell us something about the manufacturer or the ammunition. Again, that wadding that we talked about before is a piece of paper or plastic or some other composite material that pushes the shot out of the barrel when it's fired, and it comes out as well. And if it doesn't get picked up, it's left behind, you might be able to find that and learn something from it. These are some different types of wads that might be internally. So look here at the shell. We got the casing, we've got the primer, we've got the gunpowder, we've got the shots that are going to come out of different sizes. Right here is the wadding. And this wadding actually is like a cup internally. It's all in here. So this whole wad comes out of the end of the gun, and then these disperse. Then the wad drops to the ground. Okay, so here's some that have been damaged from being fired. And then here's some other types as well. Okay, so these are coming out. Other stria that you can compare, besides being able to compare the scratches on the bullet, there are other things that um, can make impressions on the cartridge. The firing pin strikes that primer charge and can create a pattern on it, and sometimes those have unique shapes and features. And if you put that under a microscope, you're going to see even more detail about it that you might be able to match to a specific firing pin. Any pattern on the firing pin is going to get transferred to that cartridge case. You're like stamping evidence right on it. Some gun manufacturers actually have microscopically created a stamp that has information about the gun right onto the firing pin. So they actually put a little ID on there. It's not highly common at this point, but it is something that exists and is possible. Um, So this is just some examples of some different types of marks that could be left on different parts of it. So we could have some scratches on the casing. Okay. We could have some patterns on the end here. So this is looking at it sideways. This is looking at the end of it, the breech face. Okay. So remember that explosive detonation sends that bullet out, but it slams the other part backwards. So when that casing strikes that breech face, those imperfections of that metal surface are also transferred to the end of that casing. So if we recover that metal casing, we can possibly compare that to the gun. So here's some modeling. In other words, like little indentations that we would see. Here's some concentric circles, okay, and other patterns that you might see. Okay, some other things that you might find on the actual ammunition itself, this would be called a head stamp. You might have a mark from the firing pin. So this would be center fire. We've got a mark from the breech face. Something has to eventually, for example, semi-automatic and automatic weapons, pull this casing out of the gun and eject it. Remember, the action is going to load, fire, and then extract that shell casing. So, where's that casing being extracted from? Something has to grab onto it. And so that can leave a little mark on here. And then once you've grabbed it to extract it, we actually eject it completely out of the weapon and throw it clear. And then we can have an ejector mark on that as well. And then we might have a manufacturer information. So you could find a lot of information on the end of this, a lot more than you might expect. In automatic and semi-automatic weapons, again, that extractor is going to eject that spent casing. And so they're going to scratch the sides of this thing in unique ways. And we're going to look for those. And so that ejector is going to leave a mark. So types of marks, again, that we could be looking for: rifling pattern, breech marks, fire pin impressions, extractor marks, ejector marks, and others as well. But these are the most common. And gunshot residue is a talk for another time.